Okay, we are now on the second part. The second part is me questions 21 through 31. It says circle I was dilated with the origin as the center of dilation to create circle 2. Which rule best represents the dilations applied to circle 1 to create circle 2? So this is my original, circle 1 is my original, and circle 2 is my prime. Okay, so what we're going to do is we're going to take a point from circle 1, which is, that point is 3, 0. And we're going to dilate it so that my next point will be where circle 2, the same point, but as a dilated picture, so the same position in a sense, but we'll get the dilated picture, which is circle 2, and that is at 8 and 0. Now, with dilations, we're always taking our dilations of the original picture, and we're always multiplying it by our scale factor, okay? So looking at my direction choices, we can eliminate 2 because they don't do anything with multiplications. Those are actually translation problems, not a scale factor problem or dilation. So now all we have to do is we're going to look at our x coordinate first, and we're going to multiply it by our scale factor. So in our x coordinate, we have 3 and we have 3/8. So we're going to multiply 3/8 times 3. So if I multiply that out, that's 9 over 8. That is not 8. So that means that is not my scale factor. So to go ahead and look at B, we have in our x we have 8 over 3. So 8 over 3 times my x coordinate 3 equals, those cross reduce, gives me 8. That is my dilation coordinates. Therefore, my scale factor is 8 over 3, so B is my answer. Okay, let's go ahead and look at number 2. Number 2, point 2 says, the managers of a restaurant reported how many people were in the different groups of customers and how much of those groups spent on food and beverages. The scatter plot below shows the data she recorded. Based on the scatter plot, about how much money would a group of 10 people be expected to spend on food and beverages at this restaurant? So what I did is I drew a trend line. So this is my trend line that I just drew right here. That's my trend line. So looking at it, we're looking at a trend line. So it says it wants to know 10 people. So looking at my graph, it's saying here is my 10 people. Okay? So as I drew my trend line, I noticed that my 10 people get somewhere right here. So it's between 140 and 120. Okay? So looking for 10 people. So looking at that, what is between 120 and 140? Well, that's going to be 135. Okay? And I can say that because if at 8 people, I'm already between 100 and 120, that means my 10th person is not going to be between that area of 105 and 115. So those are why that's not it. And as we notice, our number of people are kind of growing slowly, not as quickly, so that's why 150 can't be, that's way too high. Okay, so our answer is at 135. Let's go ahead and look at number 23. A lot of you got this wrong, not sure why. It's a simple equation. It says the model represents the equation. And it tells you that. Equation. Here's where it tells you equation. Okay, you're writing an equation. It says what? Value of x makes the equation true. So you're basically writing your equation for this side equals the equation for this side. Okay, remember to balance it. So we're going to start with this area right here. How many negative x's do you see? Well, I see 3 negative x's plus the rest. So plus how many ones do I see? I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal sign, so that's what it says. Then it's, again, how many x's do you see? And this time they're positive x's. So I see 1, 2, 3, 4, 5. So that's 5 positive x's plus how many negative ones? 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 ones. Now you have a simple equation. So what you should have used was insolve. When you put it in solve, you put this equation, comma, x, because we are solving for x. So, menu, algebra, numeric solve, and then you use your insolve. Now, since we don't have insolve and you're at home, let's do this by hand. So I want to get all of my x's on the left side. So that means I need to move my x to the other side. So to get rid of the positive 5x, I'm going to add a negative 5x, minus 5x, minus 5x. Okay, so 5x minus 5x is 0. So I'm left with negative 3 plus negative 5. So negative 3 plus negative 5 are the same sign. We just add them together. So it's negative 8x plus 10 equals negative 8. Now, I need to move my number to the other side. Just my number. So that's at 10. So the only way to move the positive sign to the other side is to get rid of it. So to move it to the opposite side. So now we're going to subtract 10 from both sides. Minus 10. Minus 10. Okay. Excuse me, I'm going to blow my nose. Hold on. Okay, sorry, I'm going to blow my nose real fast. Okay. So we know that 10 plus minus 10 is 0. Cancels out. Now we have negative 8 plus negative 10. So the same signs we add them together. So that's negative 18. And on this side, we're left with negative 8. Okay, so we extend the page. All right, oh, I'm sorry, that's negative 8x. Don't forget that x. So to get rid of that negative x, we want to get the x by itself, and it's the same negative 8 times x. We're going to do the opposite. You're going to do the opposite of multiplication, which is division. So we're going to, how to get rid of this negative 8 times x is we're going to divide by negative 8 from both sides. Okay, so that means 8 divided by 8, or negative 8 divided by negative 8 is positive 1, which is just x, equals, we have a negative divided by a positive, negative divided by a negative creates a positive. So that is 18 divided by 8, which is positive 2.25. So in your griddable, right, a lot of y'all get this all jacked up. I don't know why, but y'all just keep getting it jacked up, okay? You have a space, you have a decimal, and then you have numbers. Now, the 2 is a whole number, okay? If you see where the decimal is right here. So that means the 2 needs to be on this side of the decimal. Then you have after the decimal 2 and a 5. That's where you put your 2 and a 5. Okay? A lot of y'all decided to go behind the decimal and put 0.225. No, that's not what you see here. That's not what you see on your calculator. Alright? So just be very careful. Okay, let's go ahead and look at the next question. Okay, 24. A cylinder and its dimensions are shown below. Here's my cylinder. It gives me a radius, and we notice it gives me a height. I'm just writing that down because that's what it gives me, so let's just take notes. It says one equation for calculating the volume of a cylinder is volume equals area of the base times height, where B represents the area of the base of the cylinder. Which expression can be used to find the value of B in square centimeters for this cylinder? Okay, so I want you to find what the area of the base is. Okay, so we know, well, big B stands for area of the base. Well, looking at my cylinder, what's my base? What's my top? What's my bottom? What shape is that? Well, that shape is a circle. Okay, in that circle, we have information. I drew my circle, that's my base. We have information. We have that has a radius of 12.1. Well, hello, this is area of a base. Then we're trying to find the area of a circle. Area of a circle basically is just pi times the radius squared. Okay, it gives us that radius. It's saying pi times my radius, which is here, 12.1 squared. That is my area of the base. So our question says, which expression can be used to find the value of B in square centimeters of the cylinder? So it's not asking you to find the volume. It's asking what is the area of the base. Well, we drew our base, which gave us the area formula. So coming back to our question, what answer choices has pi times our radius squared? Well, that answer choice is F. Pi times my radius to the power of 2 squared. Okay? That's why I like to take your pictures, look at them, and draw them out. Okay, so let's go to 25. 3 groups of students use different methods to estimate the diagonal length of a patio in feet. The results were 4 and the square root of 13 feet, 14 and 2/5 feet, and 14.33 feet. Which list shows these diagonal lengths in order from greatest to least? So what I like to do is basically transform or convert these all to decimals. So we know this is a Okay, so looking at 4 and the square root of 13, we know it's 4 square root of 13, we get 14.422. I'm just going to do it to the third, to the thousands place, so that it gives us enough decimal room to see if any of the numbers are bigger or not. Okay, then we have the next one's 14 and 2/5, so we know the whole number is 14 point, and then just do the 2/5, 2 divided by 5, which just gives you 0.4. And remember, behind that 4, these are zeros, okay, so don't get confused. And then we have the already decimal 14.33. Now the first thing I noticed is that they all have 14 as their whole number, okay? So that's when I have to go look at my decimal place. Now when I look at my decimal place, I look at the first decimal tenth place, and I measure from there. We are looking for greatest to least, so I'm looking for the greatest. So looking at my greatest, I have 2 options that are my greatest one. So they're both 4, so now we have to move on to the hundredths place. And that's why we wrote our 0. So we have a 2, and then we have a 0. Well, 2 is bigger than 0, so therefore this is my greatest. So here's my first one. That's my greatest. And I know, hey, well, hello, this was, again, my 10th place. Looking at my 10th place. 4 is bigger than 3, so this is my second. And then my smallest is the one that's left over. 3. So we're looking for it to be in order from a greatest to least. So that means 4 and the square root of 13 is my greatest. The one that shows that is D. It has them listed from greatest to least. Okay, and that's why I write out to the three digits after the decimal, because sometimes you get where you have in the 10th place they're the same, and so you need to move on to the next one. Okay. All right, 26. The diagram below shows the side view of a ramp used to help load and unload a moving van. Which measurement is closest to the length of the ramp? Oh my goodness, we have a right triangle. This is something that's the easiest one. We have a right triangle, so let's list our parts. Looking at this side, what could this be? A, B, or C? Let's just say it's A. This one could be what? A, B, or C. Well, it's another length, so of course that's going to be B. And our longest side, which is always our diagonal side, is always C. Oh my goodness, so what is ABC? Like, that should trigger that you're going to use Pythagorean theorem to find the size of a right triangle, okay? We're finding the size. So, that theorem is called Pythagorean theorem. I'm pretty sure now we know A squared plus B squared equals C squared. So what are we solving for? We're solving for C. So A is 3 squared plus our B, which is 9 squared, equals C squared. Now in your calculator you will use insolve and then put comma C to solve for C. But since I'm a math teacher and I like to write, we're going to write 3 squared is 3 times 3, which is 9, plus 9 squared, which is 9 times 1, 9 times 9, which is 81, equals C squared. So now let's add 9 plus 81. You get 90. 90 equals C squared. Well, to get rid of a square, you take the square root. So we're going to take the square root of both sides. Okay? So that means C equals, and I want to give you more math. I could break this down by hand by using my little factor tree, but I won't do it to you. So let's just do the square root of 90 in our calculator because everybody has that. And we got 9.487 equals C. So looking at my answer choices, we're looking, I'll have 8.5. Well, hello, that's way too small. My whole number is a 9, so they're not going to be in. We have 10.5. No, that's too high. Then we have 13.5. That's way too high. But I have a 9.5. But that is not 9.487. Remember, it wants the closest. And look, I can round up to my 10. So that rounds up to 9.5. So my answer choice is H. Okay? All right, so back to another 27, another problem. Almost done. Which list shows the numbers below from order from least to greatest? So it wants it from least to greatest. okay? Least to greatest, smallest to biggest, that's what we wanted. And we want to make them all into decimals. So, this is a decimal, this is a decimal. Well, we have 58%. 58%, what we do is we start from behind the number, we have our decimal. We transfer it, move it 2 units to the right. 1, 2. We're now at 0.58. Okay? So 58% is 0.58. And then we have our fraction, negative 23 over 4. So 23 divided by 4 is 5.75, but since the negative sign is negative 5.75. Now when we do least to greatest, here's my number line, 0. Okay, 0. We go 1 all the way to 10, right? So the smallest number is obviously smaller than 10. But when we go on the negative sign, we have negative 1 and we have negative 10. The farther you are from 0, the less you are. So since we have negatives in here, let's look for the farthest away from 0. So we have 2. We have a negative 5.75 and a negative 5.9. Well, the whole numbers are negative 5, so that means we have to look at the decimal, or behind the decimal. We start in our tens place. This is a 9, this is a 7. Since 9 is bigger than 7, in negative world, 9 is farther than 7, so that means 9 is least. So our least number is negative 5.9. That one's done. Okay? Looking at my answer choices, now I limited myself with A and C, so I can mark off B and D. Now I know this is my second least, so this is the only other negative numbers in my bunch, which is negative by fraction 23 over 4. Make sure you go back to your fraction so that you don't get confused. So take it nice and slow. Show your work. Just take it slow and you'll get there. So we're done crossing that one out. Now we have to find which one has that. Oh, they both have negatives right from before, so then we got to keep going. Okay, so we have 0.58 and then we have 5.78. Well, which one's least? This is the 0.58, which is 58%. Okay, and the one that has 58% is C, so our answer should be C. Alright, 28. A tree in Dante's neighborhood grew 18 inches in the first 2 years after it was planted. If the tree continues to grow at the same rate, which graph best represents the growth rate of the tree in inches per year? That tells me same rate, that's saying a slope, okay? It's saying it's growing 18 inches in 2 years. So that's my y, my change in y over my x, which is 18 over 2. So if I created a table, x and y, my x is 2. So in 2 years, and the next 2 years is 4. The next 2 years is 6. If we start at 18, and then 18 more gives me 36, and so on. Okay? So first let's look at the graph where it gives you the points 2 and 18. So the first 2 years, it's saying, well, look, it's above 18, so it can't be up. The first 2 years at 18 could be this one. Well, if we're growing, well, we don't go just straight up. It's just saying in 2 years, it's on the second year, here, all the way up. That makes no sense. Over time, it's going to change. This doesn't show me over time, so it can't be H. And then J. The first 2 years, it's saying it was at 65. That doesn't match what's going on. Our rate of change was 18 inches in 2 years. So my option, my best answer is G. Okay. All right, step 9. A storage container for oil is in the shape of a cylinder with a diameter of 10 feet. So saying a diameter of 10 feet. And a height of 17 feet. Which measurement is closest to the volume of the storage container in cubic feet? So when you have a storage container, it says the shape is a cylinder. So the first thing we should do is draw a cylinder. Here's my cylinder, right? Then it says in the diameter of the cylinder, we have 10 feet. So this is 10 feet. And then it said it had a height of 17 feet. Okay? And we need to find the volume. So looking at your formula chart, for volume of a cylinder, it says volume equals area of the base times height. Now, area of the base, that's our big B. So we look, what is the shape of my base? Well, my shape is a circle. So we draw our circle. We label the information that's in our circle so far. We know that the diameter is 10. So that means we have to find the area of this circle. So the formula to find area of a circle is pi times radius squared. So we know what pi is. Pi is 3.14 times our radius. Well, it gave me a diameter. So a radius is going to be half of the diameter. So my diameter is 10. If I do 10 divided by 2, take half, it will be 5. So my radius is 5 squared. So in your calculators, you're doing 3.14 3.14 times 5 squared. You get 78.5. That is our area, 78.5 feet squared. Okay, so we found our big B. Our big B was area of the base is 78.5 squared. So we go back and plug it in. 78.5 feet squared. Now we're going to multiply by the height. So we go back to our shape, our container. Container is a cylinder. So we're taking the height of the whole thing. The height is at 17. So times that by 17. That'll give us, it'll be 1,334.5 feet cubed. Volumes to the third power. So looking at that, we know it says 0.5, so let's round it. So that's 1,335 feet cubed. And my answer choice is B. All right, 30. Triangle ABC was translated 2 units to the right and 3 units down. Write the rule that describes the translation that was applied to the triangle ABC to create the triangle A prime, B prime, C prime. So looking at it, it says 2 units to the right. Well, that's talking about my x, the x value, okay? My x value can go left or right. My y value goes up or down. So my x value is saying 2 units to the right. So on our number line, we're going right. 0, right, is your right positive versus your negative number. So if I'm going to the right, I'm going positive. So that's x plus 2. Now talking about my y, it says 3 units down. So on our number line, here's 0. Here, up at here is positive, down below is negative. So it goes 3 units down. So that means it's y minus 3. And my answer choices shows that it's going to be B. Or G, I'm sorry, G. Now, looking at this, we could have narrowed down H and J because they're multiplying. Well, we don't multiply when we translate, okay? We do exactly what it says. We have our units on our x-axis, left to right, and our y-axis, up and down. All right, let's solve one. On a field trip, there are 3 adults for every 45 students. Which graph models the relationship of the same unit rate? Again, unit rate, which is our slope. If you notice, it's going to be your change in y over change in x. Looking at my y-axis, my number line is really small, so that's how I know it's talking about 3 adults. So my change is 3 adults over 45 students. So that's our x and y. This can be simplified. It can be simplified to 1 over 15. So that means for 1 adult, there's 15. For 1 adult, there's 15 students. So if I create my x and y table, we're looking for points that, again, we start at 1 adult. It's 15. I'm sorry. Yeah, 1 adult. Blah blah blah. Sorry, got tongue-tied. So again, 1 adult, it's 15 students, or 15 students per 1 adult. So if I add 15 on this on my student side, I'm going to be at 45. I'm sorry. If I add 15, that is 30. Getting tired. That's 30. And if I add 15 more, it's 45. Over here, if I add my 1 adult, if I add my next adult, 2, they can have 30 students. If I add another adult, that's 3 adults per 45 students. So looking for a graph that pretty much matches that description. So looking at A, it says, well, 1 adult per less than, actually it's saying, 15 students per less than 1 adult, so it cannot be A. So let's look at B. We're looking for, at 15 students, we're looking for 1 adult. Well, does it say 3 adults? So it doesn't match the table. So it's not B. So let's look at C. We have for 15 students is 1 adult. So it could be this one. Let's see, at 30 students, it has 2 adults. Yeah, it definitely could be that one. Well, let's keep looking for our last one. Again, this is saying at 15 students, we're having 1.5 adults. So I don't know how you get 1.5, but whatever. Maybe you can cut somebody in half. Hopefully, Ms. Girl, it's not me. But at 30 students, saying 1.5. Well, it's not rising because the more students you have, the more adults you should be adding. So that means as my y increases, my x is increasing. This is staying the same. Cannot happen. Therefore, my answer is C. And here's part 3. So hopefully you get it done, and we'll give you due date soon. Bye.